start with any questions that you guys have, and then I can jot down a few things that I had in mind.
I don't
Any,
have any questions at the moment.
okay. All right, so I spoke to Keisha yesterday about the preparation of two figures that I think would be critical for really providing the context for a lot of the stuff that you guys are talking about. So I sent you guys the sort of the plan for those figures, and so we sat down with her and Josue to discuss the crystal structures that are going to go into these figures, and then what features of the actual cytochrome C protein are going to be highlighted by color, particularly as it pertains to Christopher section, because I thought Christopher section suffered the most from lack of context. And so by being able to highlight certain key residues and features of the protein, it would actually help to drive home many of the points that you guys are making. Because a lot of it has to do with, again, the lack of the introduction, and not just the lack of the written introductions, the lack of the visuals to really tie in a lot of the information that you guys are saying. So I sent that to you. So Keisha's going to be working on specifically on those two figures. Another thing that came out of that discussion was what would constitute a figure that would correspond to Giles' section. And so I spoke to Keisha that basically, so Giles is going to focus on like the different heme components of the cytochrome C protein. So basically, just a figure that represents the different heme moieties. In a sort of just a chem-drawer molecular representation, I think will be ideal, where there's the emphasis on the different I guess substituents, and so I think that'll be important. So there's a bit of I guess what's something's really key to understanding why this protein has its particular properties has to do with its reduction potential, and so that's something that Keisha also is including part of it in her section that focuses on insight on the actual metal. But this idea of the reduction potential is very important. I brought up at least by one other person in the manuscript as far as that number, and so it's actually critical that we highlight that because if, as you guys know, this heme moiety is present in many proteins, but those proteins, even though they include it, don't necessarily have the same functionality as cytochrome C does. And so that has to do a lot with how the secondary interactions with the metal center really dictates the ability of the metal to engage in electron transfer or even in redox. And so that's something that needs to be highlighted. The key interactions with that heme moiety, as it can really dictate the functionality of this particular protein. So that's something that is very important. So I was thinking of a figure that, and this is something really simple, but sometimes the simple sort of schematic figures are very helpful for drawing in the ideas. And so in the last portion of what constituted your guys' contribution, you were talking about potential applications. And so this serves as a good transition between your writing, which is, I would say, more the biological insight, the more fundamental, to the applied, which leads nicely into what the rest of the class is focusing on, which is the more specific anti-cancer applications. So I thought something that kind of captures that. Like I'm going to give a representation of what I was thinking about. So something like this, where we highlight some different directions that researchers are taking. And this is just brainstorming. Obviously, if you guys do decide to take this on, you can probably personalize it as the way you guys see fit. As you guys are doing a much more thorough reading of your corresponding literature than I would have. So I think something of this nature would really drive home the points of what insights people have gotten from this protein that leads to potential applications, whether they're directly of medicinal nature or therapeutic nature. Um, this kind of encompassed what the direction you guys were taking. So I had spoken to Gladys Maris about her particular section. She did have some doubts about exactly what was trying to be achieved with the development of these sort of artificial cytochrome Cs, and so I spoke to her about just kind of streamlining what she was writing about, and really what's the objective of those lines of study, and not necessarily to present many different examples, just kind of give us some insight as to what people are actually doing in that realm. And then I know that Xiaomi and Gemily have a discussion that fits in this area. Um, Again, you guys can adapt this to how you see fit. And so, in the last part, obviously corresponds to what then comes the second half of this manuscript. And so, when I compile both sections of this article, I will see how things fit best in terms of I might not keep it the way you guys have written it, so wouldn't necessarily be linear in that regard. I probably will move things around as I see that it might improve the points that we're trying to make, or maybe it works well as is just merging the two sections and providing the necessary connective tissue between the two sections. All right, so I think this would be very helpful. So something like this, coupled with the mock-up of the figures 1 and 2, and so whether they actually stay as figures 1 and 2 in your final draft, that's up to you guys to decide, but it'll be very helpful. So I already spoke to Xiaomi about some additional figures or schemes, because this technically is a scheme that we have here that could be helpful to include, which in with regards to her section, having to do with phosphorylation of the cytochrome C protein and how that might modulate to an extent the activity of this protein. So that's what, at least from my perspective, would be able to add on to what you guys have. And the one last thing has to do with Christopher's section, which I think we definitely need to have a sequence alignment of a few organisms in addition to the human one to drive home the point about the conservation of key amino acids. Um, because right now, as written, is just some, some words, but actually seeing the alignment of the sequences and seeing how many are actually conserved, I think is a common thing to do, but it's also a very helpful thing to see, that level of conservation, whether it's for structure purposes or for functionality. I think that's something that will be very important to include. So, all right. But anything that you guys have a question on or doubts about with regards to how to really finalize your contribution?
Yo tengo una pregunta, pero es más bien con BioRender.
Ajá.
Lo que pasa es que en la figura que se va a hacer de la introducción, pues el mecanismo de apoptosis se va a mantener simple. Pero para la parte de Gemily, no sé si sea buena idea resaltar el mecanismo y hacer otra figura que el mecanismo sea como que más específico.
Profesor, justo le iba a enseñar, perdón que interrumpa antes que responda, tengo una figura que puede ser un ejemplo de algo que podría hacer, porque es como un guide. No sé si quiera verla.
Of course, look at it. So yeah, if you can share it.
Sí, exacto, que eso era lo que estábamos hablando, Gemini.
Ah, ok. ¿Me dejan saber si lo ven?
Sí, we can see your Word document. Huh?
Sería como algo así para los dos pathways de apostosis. el intrinsic and extrinsic. Y entonces también tenía una que a lo mejor en la parte de Christopher, no sé si esto sea importante, pero pues estaba pensando, como yo hablo acerca de uno de los ligandos, pues había puesto esta figura también. Pero es un ejemplo, como que luego la haré yo.
Sí,
Es
sí.
de artículo.
So entonces, that I think is good to have there. It's okay to have additional protein structure. So, por ejemplo, Keisha va a incluir un protein structure of the cytochrome C, which also then highlights the heme group. In addition, she's going to have the molecular representation of how the iron is coordinated to certain key amino acids, or not necessarily the iron itself, but metals are coordinated to other amino acids. So you including that crystal structure is fine as long as you're emphasizing the amino acids that you're going to focus on in your section. Because otherwise, if it's just to include the cytochrome C protein itself, you're already going to have that image. So as long as you highlight the amino acids that you're going to focus on in your section as far as phosphorylation, I think that's very good. My one suggestion is to consult with Keisha as far as color patterning. You don't want to have a stylistically very different look from something that she may have done earlier. Okay, so just consult with each other as far as like the look or the colors that you guys are gonna go for.
Yes. Okay. Thank you.
Yeah, you're welcome. Okay, other questions? If no other questions, like I said already, a good, a really concise introduction, giving the overview of what is known about this protein. Even if it seems that you can open up a biochemistry textbook and get this information, that's not the way you're supposed to see a review article. You have to give them enough of a context and background so that when you start talking about additional features that have been very informative in terms of potential future applications, then that really helps to drive home many of those ideas, those concepts. All right. And so that's all I can give to you guys. I don't, as far as the addition of visuals and how to make your section more coherent. Okay.
Thank you. One quick question just to confirm.
Yep.
Our draft is due the 7th. Is that correct?
That's correct. Yes.
Okay.
That's Friday. Yeah. All right, guys. So I'm gonna share this recording so that the ones that had to miss can see it. All right. So then again, any additional questions, feel free to ask me, and then I will respond. And if it's relevant to everyone, I'll respond to the whole group. Okay. All right, guys. So have a great rest of your day and take care.
Thank you.
Yeah, bye-bye.
Thank you.